Welcome to this presentation about using Stata to extract survey parameters for our collaboration together. My name is Dale Rhoda. I want to acknowledge that Becca Robinson contributed substantially to the code that we're going to look at today. And I also took some ideas from this presentation from Caitlin Clary's presentation yesterday on how to do this work in R. For the things that we're asking you to do to collaborate with us, there are really 5 steps if you're going to work in Stata. First, you need to put the project programs in a place where Stata can find them. And we're going to have a short few slides and a demonstration of how to do that. Then, the reason we've asked you to collaborate is because you have some survey data sets that are interesting, and you may need to do a little bit of work to prepare your data set to run our programs on them. So we'll show you how to do that. Third, we've provided a demo program that extracts parameters from a demo data set. And so we suggest you start with that program and modify it to work on your own data set. And so we'll demonstrate that today also. And then the other steps are to send the output from that program to us so we can look it over and correspond with you. And then we'll work to get permission from the principal investigators of the surveys so that we can publish that data. So I want to talk about 2 ways to put Stata programs in your ADO path so that Stata can find them. One way is to copy the programs and the help files from the Dropbox folder that we've shared with you into a folder that Stata, your Stata, already knows about. And every Stata user has something that Stata considers to be your personal folder. So we'll demonstrate copying the files into your personal folder, and then Stata will definitely be able to find them. The second method is to tell Stata about a folder where those programs live. So if you have downloaded our Dropbox folder onto your PC, or if you use Dropbox and the folder is automatically syncing when we make updates, your folder updates on your computer, then the second method would be to tell Stata that it can find some Stata programs in one of those folders. And we'll demonstrate that method as well. Before you do either of these methods, if you start Stata and you type this command, which ICCLoop, I suspect that you're going to get an error message that looks like this because Stata does not have a command called ICCLoop. We're providing you with several Stata programs, but we'll just use ICCLoop here as the one that lets us know whether we've succeeded or not. If you type the command ADO path, then you'll see some output like that on the screen here. And you can see that on my computer, the so-called personal folder is at this path, C:ADO personal. So if I know that if I copy Stata programs into that folder, then my Stata will be able to find them. So that's the first approach we're suggesting here. So if you navigate to the Dropbox folder that we've shared with you and select these files, you're going to need these files in order to run our ICCLoop program. You can select them all, copy them, and then navigate to your personal folder and paste them there. Now if you close Stata and restart it, and type that command again, which ICCLoop, you should see some output that looks like this. It tells you the name of the folder on your computer where it finds the ICCLoop program. So if you get some output that looks like this, then you have succeeded, and Stata can now find those programs. If not, then there was some sort of a problem and you'll need to repeat the steps above. The second method, as I mentioned, if you've already saved our Dropbox folder to your computer, then you can simply tell Stata when it's looking for all the possible Stata commands it could run, it should search the folders it normally searches, and it should search one more folder also. And you can tell it, you use the ADO path plus command. And I've demonstrated it here. The programs on my computer, they live in this folder that has quite a long path name. So I've typed ADO path plus and then some double quotes, and I've put the path name in the double quotes. And when I hit return, then I type which ICCLoop, then Stata says, oh yes, I know the program ICCLoop. It lives in this path. And here's the most recent version it's saying. Either method will work. In both cases, we'll ask you to do the method now to set up your data set and have some success in extracting the parameters. And then in a week or two, we may very well have a final version, and we may ask you to download the programs again and to rerun your do file one more time to do a final parameter extraction before we assemble all of our data sets together. If you have problems with either of these methods, you can let us know, and we'll be happy to share a screen with you using Zoom or Skype and to help sort out the problem. So this is the first step to success, is to get Stata to be able to see your programs that run ICC Loop. The next step for success is to prepare your data set. You already have a data set, that's why we've contacted you, and you probably have it in a format where there's one row in the data set per child. In order to run ICC Loop, we need to have an outcome variable, and that needs to be coded 0, 1, where 0 means the child did not have the outcome of interest, and 1 means they did. Or it can have a missing value if that child or the person represented in that row is not in, for instance, in the age group that we are interested in. The second variable you need to have is a cluster ID stored as an integer, and you need to have a stratum ID stored as an integer also. A lot of times those are stored as an integer with a value label. We'll demonstrate that today. Or maybe there's no value label, and we'll talk about what to do in that circumstance. These three variables are the minimum set that you need to run our ICC Loop program. You can name those variables whatever you like. Some of you may be in the situation where you did a survey and there was only one stratum, and you don't have a stratum ID variable. That's fine. You can generate one. You can set all of the values for all of the kids equal to 1. And then our program will work, and we'll demonstrate that today. Of course, your data set might have more than 3 variables. If the survey was weighted, if you used survey weights, there will be a column or a variable that holds the survey weight. It will be important to include that as well. And you may have a variable that holds the name of the strata in a string variable instead of using a value label. That's perfectly fine. And you may very well have a survey that has more than one output. If you did a routine immunization survey, you might have a handful of outputs, several, maybe 5 outputs that we are interested in. So there might be 5 different variables for those. Some of you will have data sets that are already compatible with ICC Loop, especially if you ran Vicky to do your data analysis. Then your data sets are either compatible or very close to compatible. And some of you will have data sets where the variables are coded in a way that's not consistent with ICC Loop, and we'll need to do a little work. And I'm going to demo that in a few minutes. After you think the data set's in good shape, then again, it'll be time for you to go back to the Dropbox. This time you'll be going to the folder that's named Demo, and there are a couple of do files in there that demonstrate extracting survey parameters from the Harmonia dataset. I suggest that you copy one of those do files and then adapt it to extract the parameters from your data set. And we'll demo that in a few moments also. We keep talking about this ICC Loop program, and I just want to give you an outline. What does ICC Loop do? What is it doing? It is a nested loop. So you tell it the name of a strat-var, stratification variable, and you give it a list of outcome variables. And it loops over every stratum defined by strat-var, and it loops over every outcome in your outcome list. And then for each combination, then it extracts the survey parameters from your data set, and it puts them in a row of a new output data set. If you have only a single stratum in your survey, a single geographic stratum, and you have only a single outcome, perhaps it was a vaccination campaign survey, coverage survey, in a single stratum, then ICC Loop will make a data set with 1 row in it. But if you had a single stratum and you did a routine immunization survey with 5 outcomes, well, ICC Loop is going to put 5 rows in the data set, 1 for each outcome. Or maybe you have 5 different strata and 5 different outcomes, because perhaps you have 5 geographic strata and 5 outcomes. Well, you could call ICC Loop once, and it will put 25 lines of output in the output data set, one for each stratum and each outcome. So we call ICC Loop once for each stratification variable. We might call it with the geographic stratification variable, and then we would call it again with a urban-rural stratification variable. That's a common sequence of calls. So it would first put out the data by geographic strata, and then it would put out, for urban-rural, it would put out one row for the urban clusters and one row for the rural clusters. So we call it ICC Loop because it's extracting ICCs, although it's extracting many other parameters also. And we have the word name loop in there because it's this double nested loop to nest over the strata and the outcomes. I hope that's helpful. I just wanted to give a little outline of what it's doing. And we'll run it and we'll look at some output in a few moments also. We're not going to concentrate as much today. I'm not going to demo bundling things up and sending them to us. When you get to that happy point, then we'll correspond with you, but we want you to send us the data set, the organ pipe plots, and it would also be helpful if you send us a do file that you use to extract the parameters. And we'll help you get those to us if there are big or many, and if it's not convenient to send them as email attachments, we'll work with you to figure out how to share those. And then we'll talk more about this in the future, so I won't dwell on it today, but we're going to need your assistance in getting permission to publish the parameters from your survey also. Let's get on to the demo. I'm going to switch to Stata in a few moments, and I'll just give you a little background at the moment on the data set that we're going to look at. It's a data set from a real survey. I pulled out data from one stratum from a real post-campaign survey. The outcome variable it reflects the real data from the survey, but it needs to be recoded because instead of being coded 0, 1, it's coded 1 for yes and 2 for no. And that's a common survey coding from different organizations around the world. Sometimes people use the value 2 for no instead of the value 0. It's also from a single stratum, so it does not have a stratum ID variable. So we're going to need to add a stratum ID variable. It does have an urban-rural variable. So we're going to run ICC Loop twice on this program, once to extract the ICC for the entire stratum, and then once to extract the ICC from urban and rural respondents. So let's switch over to Stata and you can follow along. We'll make the data set and the syntax that we use today available to you in case you want to reproduce these results or follow the steps at your own pace also.
Okay, here we are in Stata. You can see that my Stata currently doesn't know about the programs for this project. So I'm going to put the demo, the ADO files folder into my ADO path. If I type ADO path, there are a number of folders here that we use to search for Stata programs, but we don't have this one, so we're going to add it. So I've added the Dropbox folder here, and now Stata knows where ICC Loop is. So we're in business. It knows where the programs are that we're going to need to do this project. So that's great. I'm going to follow Kate's protocol from yesterday and start with an empty folder. I'm going to grab a survey data set that I have sitting around from an earlier project. It's this SIA example data set. I'm going to put it in an empty folder and we'll start with that. Okay, I'm in that folder. There's only one data set. I'm going to use it and begin to explore. When we have a look at this data set, we see that there are just 4 variables. This is a weighted survey, so there are 4 variables, and they're the ones that we described earlier. There is a although we are missing a stratum ID. There's a cluster ID. Let's look at that variable. Clust, we can summarize it. We can tabulate it. We can see here that there are a few clusters with only one child in it, 2 clusters with 1 child, and then it goes up to 18, 16, 11. So this is real survey data with varying number of kids per cluster. We can look at the urban-rural variable. It's got urban and rural stored as an integer, 1 and 2 for urban and rural. That's great. We can tabulate the gut dose variable. It's yes and no, and if we take off the label, it's stored as 1 and 2. So we know we're going to need to do a little work here. We're going to want to switch that to 0, 1 variable. And let's just look at that weight variable also. The weight variable holds real numbers. Let's look at a histogram of the weight. So the weights do vary quite a bit by order of magnitude or more. And so the varying weights are going to contribute, they're going to add to the design effect in this case also. So the first thing I want to do is to save this data set with a different name. I want to make some changes, so I'm going to save it with a different name so that when I make the changes it doesn't overwrite anything in my original data file. So I'll save it with this name, SIA for ICC project, and then we'll get to work making some changes, and then we'll explore a little bit further. So the first thing we want to do is change that 1, 2 coding to a 0, 1 coding. I'm going to replace this with 0 if it's equal to 2. And then I see that it has a value label already called gotted. I'm going to replace that. There we go. So now the outcome is coded the way we want it to be with 0, 1. So we're going to save that data set that way. Now we can make an organ pipe plot. Now that it's coded 0, 1, we can look at how these data are distributed across the various clusters. Here is what we see in the coverage survey for this particular stratum. Many of the clusters have all of the kids vaccinated. The number of children, the number of respondents, we read off the scale on the right. So it averages around 8 or 9. This cluster is bigger with 17 or 18 respondents. Then we have some clusters where most of the kids are vaccinated, but not all of them. And then we have one where half the kids are vaccinated, one where fewer than half, and we have one cluster on the far right here where no kids are vaccinated. So this is real data. We see here the cluster, 2 clusters here with only 1 child. You may remember that for an organ pipe plot, the width of the bars is proportional to the sum of the weights in that cluster, and then that gives this figure the nice property that the shaded portion of the figure is equal to the coverage. So I can't estimate the area perfectly here, but it's somewhere probably in the 80% plus of the kids are vaccinated, and we'll look at that in just a moment. So this shows us how the outcome is distributed across the clusters. We can have a look at the weighted coverage here. If we survey set and do this, we can ask for the proportion of got SIA dose. We see here that 87% of the kids got the SIA dose. Here's the 95% confidence interval. By default, Stata is giving us a logit interval. If we want a different one, if we want a Wilson interval, we can ask for a Wilson interval. We see that the intervals are very similar from 74.6, this is 75.1, up to 94.2 or 94.1. They're very similar. So 87% of the kids had the outcome. That's the weighted proportion. And let's just look at that weight variable again. If we summarize the weight, we can look and see what is the coefficient of variation. It is the standard deviation divided by the mean, 3.2. So if we look at that, we can look at how much does the variability in the weights inflate the design effect. So we're going to look at, this is that term from the ICC equation that I showed you last week. So here the variability in the weights increases the design effect by a factor of 1.1. So it increases the design effect by about 10% in this case. This is one of the parameters that we extract. Another one of the parameters that we extract is the ICC. So if we look at that here, the ICC is 0.4, and that's quite high. We said last week that the conservative value in the WHO guidelines is to estimate that the ICC would probably be smaller than 1/3, but in this case it's bigger than that, and that's because of that, certainly because of that cluster that didn't have any vaccinated children, whereas so many kids did have all the kids vaccinated, and so that's contributing to the big ICC here. So these are some of the factors that ICCLoop would pull out. It would pull out the ICC, the coefficient of variation of the weights, and the weighted coverage value that we see up here. If we add, all we need to do now is to add that stratification variable, and we can call ICCLoop. So we're going to generate, we'll just call it strat. We'll give it the same value of 1 for all respondents. We'll do a label. We'll say the name of the stratum is Home Sweet Home. Of course, we would use the real stratum name if we were doing this for real. There we go. That's now we've saved the data set, and we have everything we need to call ICCLoop. So now what we want to do is to navigate to the Dropbox and grab the demo file for Harmonia, resources for working in Stata, demo, and you'll see there are a couple of do files here for working with Harmonia. I'm going to suggest that you use the one that shows more options. This shows more of the ICCLoop options. And I'm going to make the font bigger. I'm going to delete the header here. This is our demo. This is what we need to call ICCLoop. So I'm going to delete what's in the rest of the file for now and focus on this. I'm going to save this to our demo folder. Oh. Do a save as. We'll save it there. And now we just need to change the options. You can type help ICCLoop and it will remind you, Stata will remind you what the various options are, which ones are required. Those are the ones before the bracket, and which ones are optional. I've laid out most of the options here in this do file, so we just need to go ahead and change most of these. As we've mentioned before, if we haven't given you the ID or the row values yet, you can just use 0. We will tell you, when you tell us you're going to send us data from a survey, we'll tell you what values to put in for those. We need to tell it the name of the data set, and we saved SIA for ICC project. SIA for the outcome that we're looking at here is called got SIA dose. We're going to send the output to a new data set called demo ICCs. The stratum level is 1. This is the entire, everyone in the survey, so strat level is 1, sort of at the national level. This data will just pass through whatever integer you give it here. Typically we use the value 1 for national results, or everything in the survey. We use the value 2 for a subset, and we use the value 3 for a sub-subset. And so we're going to use the value 1 here. The stratification variable is called strat for this run. And it has a value label, so we don't need to include the strat name var. We'll just leave that out because this has a value label on it. The age group for this SIA I happen to know was children under 5. The weight variable is simply named weight here. The Stata survey set command for this data set, the cluster ID is called clust. There are no strata. You could say strat here, that would be fine. That's the stratum variable, and the weight variable is called weight, so we'll update that. And the comment in the comment will say that the we'll do the name of the dose. Whatever string you put in here will simply be passed through to the output dataset. And because this is our first run with this dataset, we're going to stipulate the replace option. That means if there is already a dataset named demo ICCs in this folder, it will be replaced. In this case, we know there isn't because we started in a clean, empty folder, but that's fine. So I'm going to save this program now. So I've adapted the do file for Harmonia. I've specified some options here, and hopefully when we run this code it will be successful. Oh, it looks like it's running. That's great. Please be patient while Stata calculates a bootstrap confidence interval. So the thing that takes the most time in ICC Loop is that it does 1,000 bootstrap samples, calculates the ICC 1,000 times, does sampling with replacement, sampling of clusters with replacement to get a confidence interval on the ICC. So this has now made a new data set. The data set is actually still in memory, so we'll just have a quick look here. It has about 50 variables. We extracted about 50 different parameters from that survey data set. So I've described them in memos to you before. We'll just have a quick look at the data itself here. So what's the path to the data set? What's the name of the data set? Some things got passed through. The age group, what was the outcome name, the stratum name and level, where did the organ pipe plot get saved and what is it called, how many clusters are in the data set, how many strata, how many kids, average number of kids per cluster, minimum number of kids per cluster was 1, max was 18, 20 of the clusters had 100% coverage, 1 cluster had 0% coverage. Estimated outcome was 87%. Its upper and lower Wilson bounds. The design effect was 4. The effective sample size was 50. The design effect, if we do not take stratification or weighting into account, is 3.8. The coefficient of variation on the weights is 0.32. The estimated ICC, as we saw earlier, was 0.4. That upper and lower bound of the confidence interval calculated using the bootstrap. It's a very wide interval. It goes from 0.05 0.5, essentially all the way up to 0.7. So it's a wide confidence interval because it's, well, for several reasons it's wide. Some components of the ICC, the mean squares between and within. We've passed through the comment. And then we have also calculated the upper and lower bounds on coverage using different types of confidence intervals because I'm interested. One thing we should do in our project is develop some advice about what kind of confidence intervals have what properties, so we've calculated those several ways. And that is that. So let's run ICC Loop one more time. But the second time we call ICC Loop, we just copy the code from the first time and paste it. Most of the options will remain the same. We'll change 3 options here. We're going to remove the replace option because we want to append the output instead of replacing it. And now our stratification variable is urban cluster. And this represents a subset of the data, not the whole data. So we're going to use strat level 2 here to indicate that it's a subset of the data. So I'm just going to run the whole program again here. Organ pipe plot for the whole data set, calculates the ICCs. Organ pipe plot now for, I believe, the urban, calculates the ICCs, and now an organ pipe plot for the rural portion of the data set and calculates the ICCs, and then it will finish. This program runs quite fast because this survey data set is quite small. Yours might run more slowly if you have a bigger data set. We look at the output. Now we can see 3 rows, one for the whole group, and then our urban results and our rural results. These are all the parameters, sample sizes. I want to get over. Coverage is essentially the same, 86, 87, 88%. Not much difference in coverage there. But look at the design effect. The urban design effect is 1.6 and the rural design effect is 6.1. Wow. Let's look at the ICCs. The urban ICC is 0.2 and the rural one is 0.54. And that's because of that cluster with no vaccinated kids. So let's have a look at the output. If we look in our folder now where we've been doing this work, we started with an empty folder. We copied the survey data set in. We modified the survey data set. We copied the do file from Harmonia and modified that, and it made a data set of parameters. This is one of the things we'd like to have you email to us, the data set of parameters. You can email us your do file as well. And then the program made a subfolder for organ pipe plots. This looks like the one we saw before. This is all of the data, different color scheme, but the shape of the data are the same. This is the plot for the urban the urban clusters. We can see there's an urban cluster with only 1 respondent here. There's an urban cluster with a lot of respondents here, 16 or so. And then here it is for the rural clusters. And here we see that in the rural area, most of the clusters, all the kids were vaccinated. 1 cluster, 0 kids were vaccinated. That's what's leading to that high ICC, and that high ICC is leading to that high design effect. So that's pretty interesting. We'll just have a quick look at the do file again then for Harmonia. Now that you have seen us run this ICC loop twice for this little demo, you'll be ready to see the do file for all of Harmonia. For Harmonia, we have a tetanus survey, an SIA survey, and a routine immunization survey, so 3 types of survey. And we call ICC Loop 4 times for each of the 3 types, so we call it 12 times in this program. For the tetanus, we're looking at the tetanus data set. We're looking at the tetanus outcome. We're looking at it for the entire data set, so strat level 1 and level 1 ID. Then we look at it for the provinces, strat level 2 and level 2 ID. We look at it for the health districts, strat level 3 and level 3 ID. And then finally we look at the survey parameters by urban rural, and that's a subset, so we use strat level 2 there. That's for the tetanus data set and outcomes, then we do the same thing for the SIA data set and outcomes. National, provincial, district, and urban rural. And then the same thing for routine immunization. The interesting difference here is that for routine immunization we have 5 outcomes that we're looking at. And so for each stratum, ICCLoop will make 5 rows in the data set. I happen to remember that Harmonia has 10 health districts. So this call to ICCLoop at the district level, 5 outcomes, that's going to produce 50 rows in the data set. So these 12 calls altogether produce almost 200 rows of ICCs. So you may be asking yourself, well, how do I know how many times to call ICCLoop, and at what level do we really want to stratify the outputs here? I think our guidance should be to look at the survey report, and whatever stratifying you did in that report of the coverage outcomes, let's do the same thing for these survey planning outcomes. So if you showed results for the entire survey aggregated together, let's have an ICC for the whole data set. If you had some geographic strata, maybe states or provinces or districts, well, let's have an ICC for each one of those where you reported coverage. And if you reported coverage for urban versus rural, then let's have an ICC for each of those. Maybe you broke up a post-campaign survey into age strata. Maybe you provided coverage for the kids 0 to 5 years, 5 to 10 years, and 10 to 15 years. Well, if that's the case, then let's have ICCs for those 3 groups also. And we can help you figure out how to do that with a combination of stratification variables and multiple outcome variables. So let us know if you have questions. Each person's situation will probably be a little bit different, and it may take a little bit of fine-tuning to get exactly what's appropriate for you. So I think that concludes our Stata demonstration. Thanks very much, and let us know if you have questions.